All right, today we'll begin the second part of solving quadratics. We're going to be using something called the quadratic formula. All right, so here we have our warm-up. Pause now to do it on your own. All right, you could factor and solve this first one, right? Hopefully you would notice it's a difference of perfect squares. So therefore we would get x equals negative 7 from our first factor and x equals 7 from the other factor. Does not matter which one way you wrote it first. Okay. On number 2, however, you notice that we can't do that because 8 is not a perfect number. I cannot think of a number that will multiply and add to 8 and add up to 0. So what we'd have to do for this one would be add 8 to both sides and get x squared equals 8. We'd have to square root both sides, and x would end up being plus or minus the square root of 8 because, again, we need two answers, one positive, one negative. But I can't tell you what that is. You could reduce 8. If you remember, 8 reduces to 2 root 2 because 8 is 4 times 2. That would be another option you could do, but you still end up with a number under the root. So what's the difference between rational and irrational numbers? Rational numbers can be whole numbers or reduced fractions. So 7 and negative 7 are rational. So is 2/3. So is 19. Lots of numbers are rational. However, irrational numbers have non-repeating decimals. So these are numbers like pi, surely you've heard of pi, or the square root of 2 and other irreducible roots. So if I were to type in second square root of 8, I actually end up with 2.828427125, and it keeps going forever unpredictably. So that's an irrational number. All of our answers today will be irrational. Doesn't mean you have to do anything, you just leave them under the root. On to our notes. So what we're doing today is using the quadratic equation to solve our quadratics. Okay? This is useful in two ways. Way one, if you haven't noticed, some of the numbers when we're slide and divide factoring method get very large, and y'all don't enjoy those. Also, sometimes problems are not factorable, especially when they're irrational. So you can try to factor this example, but you can't. Okay? The key here is we're still working with our quadratic trinomial, which is our second degree, right there, 3-piece formula, okay? And it still equals 0. And we'll be using this formula, okay, to solve for x. So we will get our x equals using this formula. And I like to sing it to remember it. Opposite of b plus or minus square root b squared minus 4ac all over 2a. So what we will be doing to find x is we will be replacing all the b's, a's, and c's with our a, b, and c from our problem. And it will look something like that. The key is when we have all over 2a, we are dividing both the number in front and the entire square root by 2a. You will see. Our first step really, though, is to identify what is a, b, and c. A will be our leading coefficient, which in this case is a negative 8, which I wrote ugly. B will be the next number, which in this case is negative 5, our middle number. And C is our constant in this case, which is 12. Okay? So then I start using my formula. So again, my formula is opposite of B. Right? What is B? Well, B is negative 5. Plus or minus square root b squared. So again, I'm going to put negative 5 in here. Minus 4a. All right, and then a is negative 8. C is 12. All over 2a. And then a is again negative 8. All right, so hopefully you see where every one of my pieces came from. You'll notice the formula did not change. All it changed was the letters are now replaced with numbers. Please notice inside our formula, there are no letters. There should never be. Right, so now I'm going to do my math. The opposite of b part means if this is a negative 5, a negative negative 5 will now be a positive 5 plus or minus square root. Now b squared, okay, b squared will always be positive. So negative 5 times negative 5 will give me 25, okay? And then I will then multiply these three things together. So I like to do that in a calculator. What I'm doing here is for this step is negative 4 times negative 8 times 12. And that gives me a positive 384. And here's my all over 2a, and 2 times negative 8 is negative 16. So the only thing I really have left is to reduce my, sorry, scoot this over a little bit. Look under the root and see if there's any other actions. And there are. So I'll have 5 plus or minus the square root of 25 plus 384, which is 409. And that's an irrational number, so we just leave 409 all over negative 16. There's nothing else I can really do. One key trick here, though, is if you have a negative in the denominator here, okay, all we're going to do is pop him up to be in front of the 5, so now it will be negative 5, like that, plus or minus the square root of 409 over the 16. That's not because any of the math really changed in math land. I know your favorite place. You tend to not leave negatives in the denominator because it can do weird things later. So hopefully that made sense. Let's do another. Here's my example 2, 3v squared plus 3v plus 4. And again, I'm using my formula. Opposite of b plus or minus square root b squared minus 4ac all over 2a. So again, I'm going to identify a, b, and c to start with. A is my leading coefficient 3. B is my middle term's coefficient 3. And then my last c is for constant 4. So when I do opposite of b this time, I'll be taking the opposite of a positive 3 plus or minus square root b squared, all right, 3 minus 4ac. So my a is 3 and my c is 4 all over 2a, and a is 3 again. Right, check for a moment that you see where every number came from, and now we're going to make things a little prettier. Opposite of positive 3 is going to be a negative 3 plus or minus our square root. 3 squared is 3 times 3, which is 9. And then we'll have negative 4 times 3 times 4, which is negative 48, all over 2a, which is 6. So our last action is that 9 minus 48. I end up with negative 3 plus or minus the square root of negative 39 over 6. So again, you are done there. Negative 39 on the root is going to do some weird things that we will come back to later. So your assignment today is work on these 10 problems. Let me give you some pointers on a couple of them to help you out. Number 1 and number 2 can be tricky because you got to remember that we have unwritten numbers, right? If I don't have a number in front of them, it's a 1. And I'm going to help you out and do, I think let's do 7, okay? Number 7, A, B, C. A is the leading coefficient 10. B is a secret 1, and C is negative 15. So again, opposite of B. Okay, so negative 1 here, plus or minus square root B squared minus 4AC. So I'm just plugging in B again, A goes here, and C goes here, all over 2a. Alright. When I do all this math, opposite of 1 is negative 1 plus or minus the square root. If I have 1 squared, that is still 1, because 1 times 1 is 1. Negative 4 times 10 times negative 15 is positive 600, and we're going to be over 20. So our last step is to recognize that it's negative 1 plus or minus the square root of 601 over 20, and you are done. All right, so your job is to complete 1 through 10 on your worksheet. You've got this. Good luck.